Hi all. So today we will be discussing the solutions of ISI 2025 UGA paper. The paper was easy to moderate. The UGA part was not too difficult, but however, the UGB part was slightly on a difficult side, what I feel so. Let's start with the questions. So we have the first question, which says that let A be an M cross N matrix with I comma jth entry given by the real number Aij. And here I lies in between 1 to M and J lies in between 1 to N. So now we have defined alpha. Alpha is defined to be max of J lies in between 1 and N, max of mean of Aij, and beta is mean of max of Aij. Then which of the following options are correct? So what is the meaning of this thing? Means suppose if I'm defining this matrix, just a random matrix in this sense, let's say A matrix is defined to be Aij, that is A11, A12, and then A13 and so on. We have A1 and so on, so on. Likewise, we are defining some matrix over here. We have the second row. And similarly, we have the last row. We have the nth row, which is AM1, AM2, AM3, and so on, AMN. So we have just considered one random M cross N matrix over here, right, which is having M rows and N columns. So it's saying alpha is basically max of minimum of Aij, max of minimum of Aij. So what is the meaning of this thing? So max of Aij means, suppose the minimum part is dependent on I here. So what I can say from here, so this is basically A1j, A1j, then A2j, and so on and so forth, A2j, and so on till AMJ. The meaning of this thing is basically you consider one columns over here like Aij, A1j, A2j, and so on and so forth till AMJ. So you consider all these columns over here, all these columns, first column, or let's say second column, first column, second column, third column, and so on. So you consider all these columns over here, out of which you have to select the minimum value, out of which you have to select the minimum values out of all these columns. Let's say from the first column, we are selecting this minimum value. Let's say this is the minimum value. From the second column, let's say we are selecting this to be the minimum value. Third column, may say we are selecting this to be the minimum value. So likewise, we are selecting all the minimum values from here. And then after selecting all these minimum value from the columns, we have to find out the maximum value. So that will give you alpha. I hope the logic is clear. Okay. And similarly for beta, what do? We list the columns, then we find the maximum value first. And then out of listing, and then after listing all those maximum values, we have to find the minimum value. So minimum of maximum values basically. Fine. Okay, so now what I'm doing is I'm considering a specific case for a 3x3 matrix. You all can check for a 2x2 matrix or a 4x4 matrix as well. So I'm taking a 3x3 matrix over here. So I've taken the elements in this way 1, 2, 3, 4, 5, 6, and 7, 8, 9. So now what is alpha? Alpha will be max of the minimum of the columns over here. So you select the columns and you then select the minimum value from all of these columns. So the first column, what is the minimum value? 1. From the second column, what is the minimum value? 4. From the third column, what is the minimum value? 7. And similarly, from what is beta? Beta is the minimum of the maximum values of the columns. So from the columns, you select the maximum value. So what is the maximum value over here? 3, 6, and 9 from all three columns. Out of all these, you have to select the minimum value. So their minimum value is what? 3. So here you can see one case that here alpha is greater than beta, right? So now suppose if I do a bit of changes over here, let's say I'm considering these values, let's say I'm making this as 30, 60, and 90, let's say. So what will happen? This will also change 30, 60, and 90. So in that case, the minimum value will be what? 30. Okay. So what happens in the second case? Alpha will be less than beta. So once you change these elements over here, your orientation of this inequality will change. So in general, nothing can be said. Nothing can be said in general. So option D must be correct. Okay, so we have the next question from binomial theorem. We have to find the coefficient of x to the power of 8 in this expansion. This was one of the easiest questions. You all can see from here, the expansion given over here is a very simple one. You combine these two terms, 1 minus 3x and 1 plus 3x. Once I combine these two terms, so what will I get? 1 minus 9x square, 1 minus 9x square, and then multiplied by 1 plus 9x square. All of them are having the powers to be 6. So this is one benefit which we are having. And further, these two terms can be combined and we can write this as 1 minus 9 of x square ka whole square, then whole raised to the power of 6, which means 1 minus 81 x to the power of 4 whole raised to the power of 6. So next is we have to find the coefficient of x to the power of 8. So I've done the calculation over here. You'll simplify using the binomial coefficient. So we want the term. So once you do the simplifications here, you'll end up getting something like this. And you need the terms for which the powers must be equal to 8. So you have to equate the power of x, which is 4k over here, after simplifications using the binomial expansion. After simplification, you'll find what is 4k. 4k is equal to 8. So k will be 2. So which means the third term, which means the term where k is equal to 2, which means the third term. Okay. So 60, 61, and then 62. That's why that's also one way of figuring out. So you can figure out in this way as well. Third term is the term where you'll find out the coefficient of x to the power of 8. And that is 62. 62 times of minus of 81 whole square. Right? So we just need to calculate this thing. And that's all. So finally, we must be having 62 multiplied by minus of 81 whole square, which is the same as 81 whole square. So we all can simplify this. 81 is basically 3 raised to the power of 4. 62 is 15. And 81 square means 3 raised to the power of 4 the whole square. So that's 3 raised to the power of 8. And 3 times of 5 times of 3 raised to the power of 8. So we'll be finally having 5 times of 3 raised to the power of 9. Option B must be correct. Okay, so next we have this geometry question. Consider the cyclic quadrilateral ABCD given below. So we have the cyclic quadrilateral ABCD. So here AB is equal to BC. AB and BC are equal. AD is equal to CD. AD is equal to CD. And this ratio is given by AB by AD is given to be 1 by 3. Okay. So first of all, from these conditions, from the first two conditions itself, we can clearly say that this is a kite. This is a kite. Okay. And this is a kite, and definitely, you know, this diagonal, the bigger diagonal will, perpendicularly bisect the smaller diagonal. This. Okay. So next, what we can do from here, what we need to find out, we have to find out cos of theta. So theta is this angle. This is theta. This is theta. So we have to find what is cos of theta. So what do we do? So we can use cosine rule over here. We have let's utilize this ratio. AB by AD is given to be 1 by 3, right? So AB is what? 3 times of AD. So if let's say this is x and this is x, so this will be 3x. So as this will be also 3x. So next, what we can do, we can use the cosine rule in this particular triangle. In this triangle over here, in ACD, we can find out, we can use the cosine rule. I mean, cos of theta, we can simply use cos of theta will be minus of AC square. And then here we will be having AD square plus CD square and divided by 2 times of AD times of CD. Now, what is AD square? AD means we are having 3x square plus 3x square and minus of AC square. And niche we are having 2 times of 3x into 3x, right? So after simplifications, we'll be having 9x square plus 9x square, which is 18x square minus of AC square, and then divided by similarly 18x square. Fine. So after simplifications, we can write this as, AC square as, we can write AC square as 18x square minus 18x square cos theta. Similarly, we can do the same thing for this triangle, because you see over here, this is a cyclic quadrilateral, because this is if theta. If this is theta, then this will be 180 minus of theta, right? So if cos of this becomes cos of 180 minus theta, similarly, cos of 180 minus theta will be x square plus x square minus of opposite side, which is this AC. So minus of AC square. So our logic will be to equate these two ACs. That's why we are solving this using this cosine rule. So 2 times of x into x. So finally, we are having 2x square and minus of AC square divided by 2 of x square. So here, from here, we can say AC square will be Okay, cos of 180 minus theta is minus of cos theta. So this becomes minus of cos theta. So this will finally turn out to be, once you take on the right hand side, this will become plus 2x square cos theta and plus 2x square over here. This is what we are having finally. So we can equate these two AC squares and simply find the value of cos theta from here. Okay, so we have 18x square minus of 18x square cos theta is equal to 2x square cos theta plus 2x square. So we are having 16x square is equal to 20x square cos theta. So from here we can find what is cos theta. Cos theta will be 16x square divided by 20, which is the same as 16 by 20. 16 by 20 means 4 by 5. So cos theta is 4 by 5. Option D must be correct. Okay, so we have the fourth question, which says that in the xy plane, the curve 3x cube y plus 6xy plus 2xy cube is equal to 0 represents what? So first of all, the first thing is here, this is a homogeneous equation. Okay, and the second of all is the degrees of x and y are the same. Degrees of x and y are the same. Okay, so whenever these two conditions are satisfied, any homogeneous equation which is having degrees of x and y to be the same definitely represents a pairs of straight lines. So option A must be correct. Okay, we have this fifth question. I is given to be this integral. So what do we have to do is we have to approximately find the value of this. So we can try to establish some sort of inequalities. That's what we do basically. So here x lies in between 3 and 5. So x's cube will lie in between 3 cube and 5 cube. Okay, which means this is 27 and this is 125. Then we try to create what is 1 plus x cube. So 1 plus x cube will lie in between 28 and 126. And similarly, once you take the reciprocal over here, because we need 1 upon 1 plus x cube. So once you take this reciprocal, so this orientation of this inequality will change, right? And then you can simply take this integral on all three sides. So we have integral of 3 to 5, 1 by 26 dx, 126 dx less than this will become I, because integral of 3 to 5, 1 by 1 plus x cube will be I itself. And this will finally will be having 3 to 5, 1 by 28 dx. So we are taking integral on all three sides. So this will become 1 by 126 times of 5 minus 3, which is 2, less than I, less than integral 3 to 5, 1 by 128. 1 by 28, which is 1 by 28 times of 5 minus 3, which is 2. So once you simplify this thing, this is basically 63 and this is 14 over here. So this I lies in between 1 by 63. I lies in between 1 by 63 to 1 by 14. So option C must be correct. So next we have this question from probability. Consider the two events A and B with probabilities P of A and P of B respectively, such that P of A lies in between P of A and both P of A and P of B lies in between 0 and 1. So define P of A by B to be this. It's a well-known thing. So we have considered consider the following statements. So we have to state which one is true and which one is false basically. So the first one is saying P of A given that B of C means B of B ka complement plus P of A given that B occurs is equal to 1. And the second one is saying P of A complement given that B occurs plus P of A given that B occurs is equal to 1. The second one is definitely true. The second one is taught as a basic theory. The second one is taught as a very basic theory. So the second one is true definitely. Okay, so one thing we can say from here, you all can check this thing like P of A given that B occurs. P of A given that B occurs means P of A intersection B divided by P of B. That's what we know. And what is P of A intersection B? We can write this as P of B from the Venn diagrams. Take a P of B minus of P of A complement intersection B, right? Divided by P of B. You can write this thing. So this will finally, once you divide this thing, so this will become P of B divided by P of B. So 1 minus of P of A complement intersection B divided by P of B, which is the same as P of A complement given that B occurs. So definitely P of A by B A given that B occurs is 1 minus P of A complement given that B occurs. So the second statement is definitely true. Now consider the first statement. And so the first statement says P of A given that B of B complement occurs plus P of A given that B occurs is equal to 1. Now in general, this is not true. You can check this thing. Let's say we are having P of A given that B complement. So what is the meaning of this thing? So we are having P of A intersection B complement and divided by P of B complement by the formula and plus P of A complement A intersection B divided by P of B. Okay? We are having this thing only for the first statement I'm saying. So now you can verify this thing with the help of the Venn diagrams itself. You will consider the Venn diagrams over here. This is, let's say, A, set A and set B. Okay? So I'm giving some names over here. Let's say this is X, Y, and Z. And the outermost part is basically W. So here you try to figure out what is A intersection B complement. So A intersection B complement. So the outer region. So what is this? Basically X only. X only. Intersection A intersection B complement. So what is this? X only. So X divided by P of B complement. So P of B complement is X plus W B complement except B the remaining region. So we are having X plus W and plus P of A intersection B, which is Y, and divided by P of B. P of B is basically Y plus Z, right? So now you try to, in general, you can clearly see that this is basically these two are not the same. This will not be equal to 1. You can verify this thing. So this is basically once you take this and simplify, once you take this LCM and simplify, so we have XY plus XZ, and here we are having XY plus WY. And niche, we will be having XY, X plus Y times of Y plus Z, which is XY plus XZ plus WY plus WZ. So in general, see XY is matching, XZ is matching. Then WY and this WY is also matching, but XY and WZ, these two are not matching, right? So definitely this ratio won't be 1. This ratio won't be 1. So statement 1 is definitely wrong. So option B must be correct. 1 is false and 2 is true. Okay, next we have this question which says that one function is given, which is a polynomial function. And then we have to state that f has how many roots over here? 1 real root, 3 real roots, 5 real roots, or 11 real roots. So we have a very simple polynomial given. So what we can do, we can use the Descartes rule of sign. So here what do we do is, we'll check for the number of sign changes in fx first. So what are the number of sign changes? Like plus to minus. Here we are having 1 sign changes. So there is exactly 1 real positive real root. There is exactly 1 positive real root. Right? Because there is exactly 1 sign change in fx. So we have 1 positive real. Now we see what is f of minus x. F of minus x is minus of 7x to the power of 11, minus of 4x to the power of 5, and minus of 3. Right? So here there is no sign change. All of them are minus. So there is no sign change at all. Right? So there is no negative real root. No negative real root are there. So there is exactly 1 positive real root. So option A must be correct. Okay, next we have this question which says that 12 boxes are placed along a circle. In each box, 1, 2, 3, or 4 balls are put such that the total number of balls in any 4 consecutive boxes is the same. The number of ways this can be done is what? Okay, the question is a bit hazy over here, but you can figure out what is the question saying. So we are having 12 boxes, okay? And we are having a circle first. And then we are having 12 boxes. So 12 boxes are placed along this circle. So likewise, box 1, same differing. We have box 1, we have box 2, box 3, okay, box 4, box 5, and so on. Okay, so there are 12 different boxes over here, right? Box 6, some more I'm taking, and so on. This will continue till there are total 12 different boxes. So in each box, 1, 2, or 3 balls are put such that the total number of balls in any 4 consecutive boxes is the same. Okay, so what is the meaning of this thing? So B1 plus B2 plus B3, the total number of balls in any 4 consecutive boxes will be the same. So B1 plus B2 plus B3 will be the same as the next consecutive boxes. So B2 plus B3 plus B4 plus B5, and so on. This will continue. This order should be maintained over here. Okay. This order should be maintained over here. Likewise, over here, suppose I'm taking some specific values. I'll show you by taking some specific values over here. So I'm giving this number as 1. The first box is given to be 1. This is 2, this is 3, and this is 4, let's say. I'm naming the first 4 boxes as 1, 2, 3, and 4. Okay. So you check the sum over here. So what is the sum of all these? 1 plus 2 plus 3 plus 4. 7 plus 9, which is basically 7 plus 3, which is 10. So this sum will be what? 10. Take it. Now, if this sum is 10, basically, if this sum is 10, so the next sum, so 2 plus 3 plus this must be also 10. So 2 plus 3 plus 4, 9, and this must be numbered as 1. Okay. You just simply can't put this as 5. So if this is 1, 2, 3, 4, so the next number this box will take is 1 because this sum has to be 4. This is the logic basically. Okay. So what can I say from here? So once you place the 4 balls, okay, well, once you place the 4 balls in the 4 boxes over here, for the first 4 boxes, the remaining balls will automatically get arranged with the remaining boxes. Okay, so once you place the first 4, the remaining arrangement will automatically take place. The remaining arrangements will simply automatically take place. So you just need to focus on the placement of the 4 balls into 4 boxes. So you have 4 balls. Okay. You have 4 balls and you have 4 boxes like this. You have 4 boxes and you're having 4 balls. So all of them are having how many choices? 4 choices each, right? 4 balls are having 4 choices each. So 4 raised to the power of 4. Each of them are having 4 choices, right? So 4 times of each of the boxes are having 4 choices. So 4 times of 4 times of 4 times of 4. What is it? 4 raised to the power of 4, right? So option B must be correct. Okay, so we have the 9th question, which says that A is given to be one set. XY says that XY belongs to X and Y comes from close 0 to 1. And B is one more set where XY, it's taking up XY such that XY comes from 0 to 2. So we have defined a function from A to B. And the function is f of XY is equal to X square plus Y. The mapping is defined in this way, X square plus Y and X plus Y square. Okay. So we have to state whether the function is 1, 1 or 1, 2 function. So we can check for some specific values. Let's say f of 0, 0. F of 0, 0 is basically 0, 0. So 0 is acceptable. Both of them are 0. So 0 is possible. Okay. So likewise, f of 1, comma 0. I'm checking for 1, comma 0. So 1, comma 0 will give you 1 plus 0, which is 1. And similarly here as well, 1 plus 0, which is 1. And similarly, you check for the next possible, best possible value, which is 0, comma 1. 0, comma 1 will give you, again, 0 plus 1, 0 plus 1. So again, 1, comma 1. So here you can see that for one particular input, you're getting 2 same outputs over here. Likewise, f of 1, comma 0 is 1, 1. And then f of 0, comma 1 is 1, 1. Right? So for 2 different inputs, basically, you are getting the same output. So definitely the function is a many to 1 function. So function is not 1, 1, right? Function is not 1, 1. So option A is gone and C is also gone. Okay. So now we check for on-to part. We'll check for on-to part. So for on-to, we are having, what do we have to prove? Because the range set is what? Range set is XY. The range set is saying XY belongs to 0 to 2. So what we have to prove is the codomain part is 0 to 2. So the range part, we have to check whether the range part is also lying in between 0 to 2 or not. So one thing we can say from here, let's say here, both of these X and Y are lying in between 0 and 1. Both of these X and Y are lying in between 0 and 1. So X square also lies in between 0 and 1. So as Y square also lies in between 0 and 1, right? Fine. So first we are having X square plus Y. So X square plus Y will lie in between 0 and 2. X square plus Y will lie in between 0 and 2. Right? And so technically this should the 0 and 2, the value of 0 and 2 should be acceptable over here. But this will actually not take the value. And similarly, x plus y square, x plus y square should also lie in between 0 and 2. But you will see that this value is not acceptable over here. This value is not acceptable over here. This 2 part is not acceptable. 2 is not possible over here. I'll say the reason for it. Because x square plus y is there. If x square plus y is equal to 0, let's say, okay, x square plus y square is equal to 0, the output, I'm thinking from the output point of view. So for instance, if this is x square is a non-negative quantity, so the minimum value of this is 0. X square is a non-negative quantity and their sum has to be equal to 0. Okay, it's a non-negative quantity and their sum has to be equal to 0. So when this is possible, this is only possible if x is equal to 0 and y is equal to 0. This is the only possibility. Two small numbers are there. Okay, here x comes from 0 to 1 and y also comes from 0 to 1, right? And this is x square, which is a non-negative quantity. So the minimum value is what? 0. And their sum has to be 0. So this quantity has to be 0. So 0, x must be 0. And similarly, y also has to be 0, right? And same thing goes for this as well. So x square, x plus y whole square, x plus y square, which is 0. Okay. And similarly, this also. This quantity also you have to take for this to be 0. Y has to be 0. If y is 0, so x also has to be 0, right? So once you think from this pair point of view, we are having this pair to be x square plus y and then x plus y square. So once you think from this pair point of view, if one is 0, then the second one won't be 2 at least. This 0, 2 pair is not possible. Okay, so 0, 2 is not possible. This, if you are making this to be 0, this has to be 0 as well. So this 0, 2 pair is not possible over here. So definitely this fails for, this is not for some specific value, this is not attending to. So obviously this function is neither 1, 1 nor on 2. Option B is correct. In fact, there are several other values which this will not attain. So as 0, 1, this will not take the value of 0, 1 as well. 0, 1. This output cannot be 0, 1. Okay, so 0, 0 is one of this output. This output cannot be 0, 1, or let's say any other output, let's say 0, 1 by 2 or something. This will also not be attained over here. So these outputs are not possible. So as 0, 2 is also not possible. So definitely the function is not 1, 1, neither 1, 1 nor on. Okay, so we have this question which says that you have to find the number of ordered pairs AB of positive integers with A less than B, and it's satisfying this relation A square plus B square is equal to 25. So Diophantine is given, A square plus B square is equal to 25. So we have to find the, basically we have to find the number of solutions of this equation. First of all, you can clearly see from here this 25, we are having A square plus B square is equal to 25. So always whenever you are giving the exam, whichever year you're giving the exam, you should remember the factorization of that particular year. Okay, whether it's a perfect square or not. So likewise over here, 2025 is 45 square. This year is a perfect square. So 2025 is a perfect square. So 45 square. So one thing to we can clearly see from here, there is one, definitely there is one Pythagorean triplet which is quite visible from here, because see 3, 4, 5 is one of the standard most triplet. Okay, 3, 4, 5 is one of the standard most Pythagorean triplet. So if you multiply the same by 9, so this will become 45, 36, and this is 27. So 27, 36, and 27, 36, and this is equal to 45. 27, 36, and 45 is definitely one Pythagorean triplet which we're getting over here. Okay, so 26 and 30, 27 and 36 is definitely one of this ordered pairs. So option A is definitely wrong. So 0 is not possible. Definitely you're getting some solution over here, right? Okay, so now you can verify this thing that this is the only solution which we can verify. Let's say we can take with the help of some congruence modulo over here. We have any particular number. We know any number is congruent to 1 modulo 3 or 0 modulo 3. Any perfect square. We know any perfect square is congruent to 0 or 1 modulo 3. Okay. So the right hand side, now here we have the right hand side to be 45 square, right? So 45 square is what? Congruent to 0 modulo 3. You can check the right hand side is congruent to, this right hand side is congruent to 0 modulo 3. Okay. So if the right hand side is congruent to 0 modulo 3, a square plus b square must be also congruent to 0 modulo 3. This must be also congruent to 0 modulo 3. Okay. So now a square, whether it's a square or b square, both are basically square numbers. So a square or b square, and the right hand side we are having 0, right? So a square or b square must be also congruent to 0 or 1 modulo 3, because both of these are perfect squares. So 0 or both of them must be congruent to 0 or 1 modulo 3. Now the only possibility will be 0 modulo 3, because the right hand side is basically 0 modulo 3, right? So the only possibilities are 0 modulo 3. So a and b are, whether it's a or b, both of them are congruent to 0 modulo 3. So now if they are congruent to 0 modulo 3, so they are multiples of 3. A and b are what? Multiples of 3. So a will be what? A will be 3 times of k1 and b will be 3 times of k2, because both of them are basically multiples of 3. So I'm taking this to be k1 and k2. So we are getting 3 times of 9k square. So from this relation, we are getting 9k1 square plus 9k2 square. And this is equal to 2025. Okay. So k1 square plus k2 square is now reduced to 225. 2025 divided by 9 will give you 225. And 225 is once again, 225 is once again congruent to 0 modulo 3. Again, this will be congruent to 0 modulo 3. So once you keep on calculating this thing, you will see that the pairs will start repeating over here. So 225 is congruent to 0 modulo 3. Okay. So once again, we can say that this is a multiple of, again, similarly, k1 and k2 are multiples of 3. By the similar logic, k1 and k2 will be congruent to 0 modulo 3. Right? K1 and K2, by the similar logic, K1 and K2 will be congruent to 0 modulo 3. And so definitely K1 and K2 will be, by the similar logic, K1 and K2 are multiples of 3. So K1 and K2 are multiples of 3 means, I can directly say from here, K1 and K2 are multiples of 3 means K1 will be, what can I say? K1 will be 3 times of K2, right? And similarly, K2 will be, or K3, let's say, and K2 will be 3 times of K4. Okay. K1 is 3 times of K3 and K2 is 3 times of K4. So from here, what can I say from here? So K1 square plus K2 square. So this will give you 9K3 square plus 9K4 square. And this is equal to 225. And so similarly, K3 square plus K4 square will give you 225 divided by 9, which is 25. So 25, once again, it's a perfect square, 5 square, right? And 5 square, you know, 3, 4, 5 is one of the standard most Pythagorean triplet, right? It's one of the prime Pythagorean triplets which you all face. So 3, 4, 5 being one Pythagorean triplet. So definitely 3, 4, 5 is the solution. So A and B must be 3, 4. A and B must be 3 and 4. So there is only one solution. I mean, this solution keeps on repeating. They have also said A and B must be, A must be less than B. They have said A must be less than B. So definitely here 3 is less than 4. So definitely there is exactly one solution. This solution will keep on repeating. Further, you will take 0 modulo 3. Okay, this is congruent to 0 modulo 3, and you continue with the same logic. So you will end up getting the same solution, 3 and 4 as well. So definitely there is exactly one pair in this case, so which is option B. Okay, next we have this question which says that for each n greater than or equals to 1, let an and bn be real numbers such that n is not equal to 0 and bn is also not equal to 0. And we have one relation given. So we have to find out which what is an and bn over here. So it's kind of a mixture of complex numbers as well as sequences. Okay. So here by looking at this relation, we can take the feeling of, we can get the feel of what do you call that? De Moivre's theorem or Euler's expression. So what I do, I define the sequence in such a way, I define this complex number Z. Okay. I define this complex number Z in such a way that an plus I bn. I define this complex number Z to be an plus I bn. So what we have to do is we have to solve this relation Z to the power of n is equal to n times of Z. That's what we need to do. Z to the power of n is equal to n times of Z. Okay, and here definitely Z is non-zero. Z is a non-zero quantity because these sequences are non-zero quantity. They have mentioned AN is not zero and BN is also not zero. Both AN and BN are not equal to zero. Okay. So Z cannot be zero. So what we can do from here? We can write this as Z to the power of n minus 1 is equal to n. Okay. So next I am rewriting this Z as in terms of E. So this Z is the same as R times of e raised to the power of I theta whole raised to the power of n minus 1. And this is equal to n. Okay. So from here we can separate this thing. So we are having R raised to the power of n minus 1 times of e raised to the power of I theta whole to the power of n minus 1. E raised to the power of I times of n minus 1 times of theta. And this is equal to n. So what are the possibilities? What are the cases what we can make from here? So one case, so we can clearly see that if I equate R raised to the power of n minus 1 to be n, this is the first case I'm taking. R raised to the power of n minus 1 to be n and e raised to the power of I times of n minus 1 to be theta. Let's see what we can get from here. Okay. So if I take this case, so definitely R is what? R is n raised to the power of 1 upon n minus 1. And in the options, we are getting some sort of n raised to the power of whole to the power of 1 by n minus 1 is there. Okay, next we solve this thing as well. So here we are having e raised to the power of n minus 1 times of theta. So if I talk about this argument of this thing, so kind of this is e raised to the power of I times of n minus 1 times of theta, and this is 1, which is the same as e raised to the power of I times of 2 k pi. This is the same as 2 times of e raised to the power of I times of 2 k pi. So this is actually n minus 1 times of theta. So once you equate these two, so we are getting n minus 1 times of theta is the same as 2 k pi, right? And so theta will be how much? Theta will be 2 k pi divided by n minus 1. 2 k pi divided by n minus 1. So we are getting R to be this and theta is this in the first case. So definitely we can say from here. So what is R? R is n raised to the power of 1 upon n minus 1 and cos of 2k pi divided by n minus 1 plus n raised to the power of 1 upon n minus 1. Again, similarly, plus I sine 2k pi divided by n minus 1. Okay. And this is once for specific value. We are getting k over here. For specific value, they have taken if k is equal to 1. So you will end up getting this thing. So definitely option D is correct. Okay. Next, we have this question. Now some relation is given. A naught is 0, A1 is 1, and AN is given to be 5 AN minus 1 plus AN minus 2. Now the value of this determinant of A101, 100, A100, A100, and A99. So we have to figure out we have to find the value of this determinant. So now suppose this is D. Okay, D is given to be this. So once you simplify this D, what we'll have? We'll have A100, A101 times of A99 minus of A100 and A100 square. That's what we are having. This determinant D is now simplified to A101 times of A99 minus of A100 square. Okay, so once you simplify this thing, what are we having? So we have to take the help of this as well. AN to be 5AN minus 1 plus AN minus 2, right? What I do, I take the general form of this determinant. Here we are getting A101, 99, and then 100. So what I'm doing is I'm writing this Dn as AN plus 1, AN minus 1 times of AN minus 1 minus of AN square. So what will happen from here? From this relation itself, we can figure out what is D1. So what is D1? D1 is what? D1 will be A2 times of A0 minus of A1 square. A2 times of A0 minus of A1 square. Okay. So what are these values actually? We can figure out these values from here. We can find out what is A2 from here, from this relation. A0 is given to be 0. A1 is given to be 1. So let's find out what is A2 from here. What is A2? A2 will be 5 times of A1 plus A0. So this will become 5 times of 5 plus 0 will give you 5. So this is actually 5 times of 0 minus of 1 square, which is actually minus 1. So D1 is minus 1. So let's find out what is D2. So D2 will be what? D2 will be A3 times of A1 minus of A2 square. Again, we find what is A3 from here. So A3 will be what? 5 times of A2 plus A1. So 5 times of A2 means 5, and plus A1 will be 1. So 26 from here. So this is basically 26 times of 1 minus of 25, which is equal to 1. So similarly, you will calculate what is D3. You will obtain D3 to be minus 1. You can do the calculation, check. You will obtain D3 to be minus 1, D4 to be plus 1, and so on. This pattern will keep on going on. Okay. This pattern will keep on going on. So dn will be, in general, dn will be minus 1 raised to the power of n. Dn will be minus 1 raised to the power of n. For 1, we are having minus 1. For 2, we are having plus 1. For 3, again, we are having, for odd values, we are getting minus 1. So minus 1 raised to the power of n. So next, from here itself, we can find what is this relation. What is this? Basically, we have to find the value of this d, right? So what is this d? D is basically, we have to take the value of n to be 100, right? This is dn, where n is equal to 100. And d100 is what? D100 is what? D100 will be even number, so minus 1 raised to the power of 100, which is nothing but 1 only. So the value of this determinant will be 1. Option C must be correct. Okay, next we have this question which says that the lengths of these 3 sides of a right angle triangle are in geometric progression. The smallest angle of this triangle is what? So we have one triangle, a right angle triangle is there, whose sides are in geometric progression. Let's say ABC triangle is there. So this is, the sides are in geometric progression, AR squared, let's say. Okay. So we can use the Pythagoras theorem to figure out some values over here. Like, let's say Pythagoras, if we use the Pythagoras theorem, so we are getting a square plus a square r square. So you simplify from here. So we are having a square r is 3 power of 4 is equal to a square common. So we have 1 plus r square. And from here, we are getting one quadratic. A square cancels out. So we are getting one quadratic in terms of r. So we have r is to the power of 4 minus of r square. Minus of 1 is equal to 0. Right? So we are getting a quadratic in r square. You can take r square as t and then solve, which is t square minus of t. Minus of 1 is equal to 0. So what is t? T will be 1 plus minus root over of d square minus 4ac. So 1 plus 4 divided by 2. So this is nothing but 1 plus minus root 5 divided by 2. Now we are getting plus minus root 5 divided by 2, which means this is r square. Actually, the value of this is r square. R square is 1 plus minus root 5 divided by 2. Now we can't take the negative value because the negative 1 minus root 5 will give you a negative value. So r square cannot be negative, right? So r square has to be 1 plus root 5 divided by 2. R square has to be 1 plus root 5 divided by 2, right? This is the final value of r square. So now they have asked to find what is the smallest angle of this triangle. Smallest angle of this triangle. So we find out what is theta from here. We find what is theta. In general, let's find what is theta. So can we find theta? Now we have r square. So let's utilize this r square. So we can find what is sine theta. What is sine theta? Sine theta will be a upon ar square. Sine theta is how much? A upon ar square. So this a and a will cancel out, which is just simply 1 upon r square. So 1 upon r square means 2 upon 1 plus root 5. And then you simply rationalize this. So we will be having 2 times of root 5 minus 1. And niche we will be having 1 plus root 5 times of 1 minus root 5, which is root 5 minus 1, root 5 whole square minus of 1 square. So 5 minus 1, which is 4 over here. So final answer, we are getting theta. Theta will be sine inverse root 5 minus 1 divided by 2. So option D must be correct. Okay, next we have this question which says that the lengths of the 2 adjacent sides of a parallelogram are 2 centimeter and 3 centimeter. The length of one diagonal is square root of 90 centimeter. Then we have to find the length of the other diagonal. So we have the parallelogram given. We have a parallelogram and they have asked to find and they have given the lengths of the 2 adjacent sides. Okay, so this is let's say this is 2 and this is 3, and similarly this is 3 and this is also 2. Okay, the lengths of the 2 adjacent sides are given, fine, to be 2 and 3. So the length of the diagonal, one of this diagonal is also given to be square root of 90. The length of this one of this diagonal is also given to be square root of 19. So what we have to do is we have to find the length of this other diagonal over here. So there is a direct result which we can use from here. It's known as the parallelogram law. So d1 square plus d2 square is equal to 2 times of a square plus b square. It's a basic formula which is taught in class 10th. So d1 square plus d2 square is equal to 2 times of a square plus b square. And we have all these values. So d1 square, we need to find d1 square or d2 square, whatever. So d2 is given to be root 19 whole square. So 19 is equal to 2 times of 2 square plus 3 square. So rest is calculation. How much is this? This is just directly 26. This is 19. So d1 square is 26 minus of 90. This is 7. So d1 is basically root over of 7. So option B is correct. Okay, next we have this question, which says that consider the following statements about two similar triangles. So S1, S2, S3, and S4 are given to be four statements. So you have to just see that which one implies which one. So which statement implies which statement. So statement 1 is saying lengths of the sides of a triangle 1 are an arithmetic progression. So AP. So statement 1 is saying, let's say you have two triangles. First of all, we are having two triangles. We are having two triangles, which is having one triangle is having sides ABC, and the second triangle is having two similar triangles. No, these are two similar triangles. So the second one is having KA, KB, and KC. Two similar triangles are there. So statement one says ABC are in AP. Statement 1 says ABC are in AP. Statement 2 says ABC are in GP. ABC are in GP. Statement 3 says KA, KB, and KC. KA, KB, and KC. They are in AP. And statement 4 says KA, KB, KC are in GP. So now we have to see that which one implies which one. So now it's statement. So the first option says that statement 1 implies statement 3, but statement 2 does not imply statement 4. S1 implies S3, which means ABC implies KA, KB, KC. ABC are in AP. Will this imply KA, KB, KC are also in AP? Definitely yes. You multiply the numbers by some constant K, that will still remain to be an AP. So definitely S1 implies S3. Achha, S2, now it's saying S2 does not imply S4. Let's see. S2 does not imply S4. So will S2 imply S4? ABC are in GP. So KA, KB, KC, will they be in GP? Definitely yes. If you multiply, if ABC are in three numbers are in GP, you multiply the ratio by K, by some constant K, that will still remain to be a GP. Okay, so S1 implies S3, and also S2 also implies S4. So option C must be correct. Okay, next we have this question. So here the question says we have to box of x denotes the greatest integer less than or equal to x belongs to R, and mod of x has its usual meaning. So basically we have to find the value of this integral. Integral minus 2 to 1 box of x plus 2 times 2 raised to the power of mod of x dx. We have to find the value of this integral, and it's a very straightforward question, not a difficult one. You just need to evaluate this integral by breaking the box. Like box is here, integration goes from minus 2 to 1. So first of all, box function, this will break at integer point. So we have to first separate this and write this as minus 2 to minus 1. Then this will be broken from minus 1 to 0. And then the third one will be from 0 to 1. Okay, that's how we break this. And then we decide this thing. So in between minus 2 to minus 1, box of x is what? Minus 2, right? So this will be minus 2 plus 2. And then whole to the power of mod x. Now, what is mod x? In between this region, mod x is negative only. This is the negative region. So mod x is what? Negative only. This will open up with a negative sign, dx. Okay. And similarly, so next we are having minus 1 to 0. So in between this region, box of x is what? Minus 1. So plus 2 raised to the power of, once again, the region is still negative. So box of mod of x is what? Minus of x dx. And lastly, we are having this. So 0 to 1, in 0 to 1, box of x is what? 0. So 0 plus 2 raised to the power of mod x. Now here the region is positive, so this will be positive x. So next, we have to just solve this thing. Now this is straight away 0, minus 2 plus 2 is just straight away 0. So next we have to just evaluate this integral. How much is this? This is 2 minus 1, which is just 1 only. So 1 raised to the power of minus x is the same as 1 only. So this is straight away 0 minus minus 1. Dx is what? X. And then you plug in the limits from minus 1 to 0, which is 0 minus minus 1. And then plus then this is basically 2 raised to the power of x. So 2 raised to the power of x ka integral is basically 2 raised to the power of x divided by ln2. And then range goes from 0 to 1. Okay. So this is finally, so 1 is just, minus minus plus 1. This becomes plus 1 and plus. So 2 raised to the power of x, 2 raised to the power of 1, so which is 2, 2 by ln2 minus of 2 raised to the power of 0, which is 1 divided by ln2. And so finally we are having 1 plus 2 minus 1, which is 1 plus 1 upon ln2. Option A is correct. Okay, so next we have this question, which says that fx is given to be one function. Then we have to state whether the function is having local maxima or local minimas at these specific points, plus minus 1 or 0. Basically, we have to analyze these points actually. So plus minus 1 and 0, all these will come from here itself, from this function itself. We can clearly see one thing. Now, it's better if we plot the rough diagram of this particular function. If you carefully see that the function is an even function, you all can check this thing. The function is an even function. Fx is equal to f of minus x. The function is an even function. Okay. Put the value of x as minus x over here. You will see that this will still remain to be the same as fx. So this function is an even function. So this function is symmetric. F is symmetric about the y-axis. Symmetric about the y-axis. It's a property of even functions. So when a function is symmetric about this y-axis, so what we can do, we can study the behavior on the right-hand side. I mean on the positive side, and then we can simply reflect the same on the negative side as well. Fine. So what I do, first of all, I study the behavior of this particular graph at some of the turning points, some of the points which are being mentioned, like 0 and 1 is there actually. So 0, 1, okay, minus 1 is also there. Likewise, I said if 1 is there and minus 1 will definitely there. Obviously, you all can see, clearly see from here, like the turning points are from here, the turning point is 1, minus 1, and turning point is 1. So definitely there will be some changes, definitely will be there, which will take place at 1 and minus 1, right? So we need to study the behavior in these regions actually. So I'm saying that this is an even function. So we'll study the behavior on the right hand side, and then we'll reflect the same thing on the left hand side. So let's see what happens for x greater than 1. So if x is more than 1, we'll study the behavior of the function. So fx is what? First we define the function. Fx will be what? If x is more than 1, this will be 1 upon 1 plus x minus 1. And plus this will be 1 upon 1 plus x plus 1. The mod will come up with the positive signs, and this will become 1 upon x. 1 cancels out. So 1 upon x plus 1 upon 2 plus x. So we'll be having this thing. Okay. And if x is less than 1, what happens? So if x is less than 1, what happens in this region? So fx will be what? Fx will be x is less than 1. So this will be 1 minus x. This will be 1 minus x. This will be 1 minus x. So 1 plus 1 minus x. So 2 minus x. This will be 1 upon 2 minus x. Plus, again, what will happen to this? X is less than 1. Okay. But x is greater than minus 1. X is greater than minus 1. So this will remain to be the same. This will remain to be the same as x plus 1 only. So 1 plus x plus 1 will give you 2 plus x. So once you take this LCM, so 2 minus x times of 2 plus x. So this will become 2 plus x plus 2 minus x. So cancels out. So we are having 4 upon 2 plus x times of 2 minus x. This is the function on this side actually. Okay. Acha, there are certain things to see from here. For instance, on this side, for instance, what happens for x more than 1. So for x more than 1, one thing you can clearly see, as x increases over here, as x increases, the overall fraction will decrease. Okay. As x will increase, the overall fraction will decrease. So here in this region, the function is decreasing. In this region, the function is decreasing. So the function will go down rapidly. Okay. Also, now for this region, what will happen for this region? We can try to plot the rough sketch of this particular graph. Okay. Now you can differentiate from 0 to 1, you are getting this function. So you can differentiate and find whether like in between 0 and 1, whether the graph is increasing or decreasing. But if you try to carefully visualize a bit, okay, f of 0 pe function value you all can check. F of 0, what is the function value at f of 0? F of 0 pe function value will be what? 1. F of 0 pe 1. And from here, we can check the function value at f of 1. We can check the function value at f of 1. So f of 1 will be 1 plus 1 by 3, which is 4 by 3. So kind of the function is increasing from 1. So here the function increases. See, this was f of 0 was 1. And then once you increase the value, the output is also increasing. So f of 1 pe, we are getting 4 by 3, which is more than 1. So the graph is increasing from here. The graph increases and then decreases from here. Got my point? The graph increases and then decreases. So likewise, if I try to plot the rough sketch of this graph, so we are again 0 at 1, 0 pe 1, then 1 pe we are getting at x is equal to 1, we are getting 4 by 3. So slightly more than 1, 4 by 3. Now after 4 by 3, the graph will decrease. After 4 by 3, the graph will decrease. Okay. After 4 by 3, the graph will decrease. Likewise, from here, the graph will keep on decreasing like this. Decrease, decrease, and then the graph will go in this way. The graph will keep on decreasing. Okay. But the graph will not cross the x-axis, because as x tends to infinity, this will tend to 0. As x tends to infinity, this quantity tends to 0. This quantity also tends to 0. So fx tends to 0. So we can say that this will come very, very close to the x-axis. Okay, so your x-axis is acting as the asymptote to this graph. So now in this region 0 to 1, 0 to 1 mein, the graph is increasing. This value is increasing. The output is increasing from 1 and goes to 4 by 3. So this is increasing. So from here, the graph is increasing. So this is the graph, actually, rough sketch of this graph. And then you reflect the same graph on the left-hand side. You reflect the same graph on the left-hand side. Okay, so there is not so much of space over here. So once you reflect the graph, you'll be having something like this. Okay, and this point will be definitely -1. Reflection, it's just the reflection. So if this is 1, so definitely this is -1. Okay, fine. So clearly, we can see one thing from here. So there exists one maxima. So one local maxima here, and then one more local maxima. So two local maximas are there at +-1. So local maximas at +-1, and there is one local minima at 0 from this graph itself. So there is one local maxima, two local maximas at +-1, and one local minima at x is equal to 0. So option D is correct. Okay, next we have this question where this function is given, and then this f is defined to be fx to be -5 integral -5 to x f of t dt. Okay, so we have to check whether this function is continuous or not. Okay, continuous or as well as differentiable or not. As per the options, we have to check the differentiability and the continuity of this function. So what do? We can make some cases over here, because this integral is going from -5 to x. And this function, if you carefully see, this function is given to be signum of x. This is nothing but signum x is given. Okay. Okay, so what I do, I take the first case. Now here we are having from -1 to -5 to x, right? So case 1, the function is breaking at 0. Also, what we need to see is that the function is breaking at 0. So the first case, I'm taking this to be x is less than 0. So what happens for x is less than 0? Okay. So when x is less than 0, you see over here, x is less than 0. We have the minimum point to be -5, and max to max, this is actually 0. So your x is less than 0 means x is somewhere over here. X is somewhere over here, right? X is somewhere over here. So in this case, can I say this integral -5 to x, f of t, here x is less than 0, right? So x is somewhere which is less than 0. So if something is less than 0, this integrand will become -1. Integrand will become -1. So can I say that ft will simply become -1. So -1 times of dt, right? So which is -t, and range goes from -5 to x. So this will become minus of x plus 5. So which is nothing but 5 minus x. Okay. Now suppose I consider the case 2, second case. In the second case, I consider what happens for x is more than 0. Now for x is more than 0, we have this is -1 and this is 0. So x is more than 0 means x is somewhere over here. X is somewhere over here, right? So what happens? Because x is somewhere over here, we have to you cannot directly reach to x right away. You cannot directly reach to x right away. So you have to break from -5 to 0, and then 0 to x you have to break, because at x is equal to 0, the definition of the function changes, right? So you have to define from -5 to 0, and then once again from 0 to x dt. So -5 to 0 mein, -5 to 0, in between -5 to 0, this is taking -1, because this is still negative. In -5 to 0, this region is what? X is less than 0. And in x is less than 0, ft is what? -1. And similarly, from 0 to x, something is greater than 0. In 0 to x, it's positive, right? For more than 0, it is directly 1, right? It's directly 1. So ft will be 1 itself. So -5 to 0, -1 dt plus integration 0 to x, 1 dt. So next we solve this thing. So this is directly minus of t dt, and then once you plug in the range, so we will be having 0 minus of -5, so 0 plus 5. And plus this is directly dt, which means t, so 0 to x, which means directly x. So we are having x minus 5. Okay. And case 3, last case is where you can take x to be 0. If x is 0, then directly this integral will become -5 to 0. Okay, -5 to 0, -1 dt, because you're taking x to be 0. X to be 0 means here only you're directly taking x to be 0. So -5 to 0 and minus of 1 dt, because -5 to 0 means the region is still less than 1. So -1 dt. So which is minus of 0 plus 5, which is -5. This is -5. So we have two things over here, three things over here, first of all. So for we have just defined the function. We can just define the function fx. Fx is basically x minus 5 when x is greater than or equal to 0, right? When x is greater than or equal to 0, we can take x minus 5, and when x is less than 0, we can take this to be 5 minus x. 5 minus x. For x less than 0, we can take it to be 5 minus x. Now I have taken a greater than or equal to sign over here, because once you take x to be 0 over here, so this will become -5. This will become -5, and -5 will cover up the case 3 as well. -5 will cover up the case 3 as well. Fine. So that's why I've taken one greater than or equal to sign over here. So this is our function actually. This is our function x minus 5 when x is greater than or equal to 0, and 5 minus x when x is less than 0. Okay. Now, if we see the graph of the function, the graph will be somewhat like this. The graph will be somewhat like this. First of all, clearly we can say that the function, this function is not continuous at 0. Except at 0, it is continuous everywhere. Except at 0, it is continuous everywhere. So it's not continuous at 0. We can clearly see from here itself. Otherwise, you can check the graph of the function. The function will be somewhat like this. At 0, we are getting -5. At 0, we are getting -5, right? For x is greater than or equal to 0, we are having x minus 5. So x minus 5, the graph looks somewhat like this. X minus 5. So we have x. The graph of x looks like this. Y is equal to x. And then we are shifting the graph by 5 units down. So that will become x minus 5 like this. But we have to take for this region, x greater than or equal to 0 ke liye, we are getting this graph to be x minus 5. This is y is equal to x minus 5. And if x is less than 0, it's 5 minus x. So y is equal to minus x plus 5. So minus x, the graph of minus x, you're drawing the graph of minus x. Then plus 5 units, you're shifting up. So your graph of y is equal to minus x will be somewhat like this. Acha, x pe 0 pe. Suppose at x is equal to 0. What is the function value? 5. Function value is what? 5. Open 5. So your graph will be somewhat like this. Graph will be somewhat like this. Clearly, it is discontinuous at 0. Clearly, the graph is discontinuous at 0. Okay. So I think the option framing the option is, is what I think is not appropriate over here, because it's saying not continuous. So technically option A is also correct. Not continuous where? Not continuous at 0. This is the function is not continuous. You can check the limiting value as well. You check what is f of 0 plus and what is f of 0 minus. Both of them will not be the same. One will be plus 5 and the second one will be minus 5. So limiting value won't be the same. Okay, so clearly the function is discontinuous, and if this is discontinuous, so definitely this is not differentiable at 0. So a more appropriate option will be option D, differentiable everywhere except at 0. Okay, next we have this question which says that for a real number x, let fx is given to be, fx here is given to be minus of integral minus 20 to plus 20 g of t, g of x minus t dt. And g of x is given to be this function, 1 if x belongs to 0 to 1 and 0 the remaining cases. So what I do, I define this thing first, because we have the function g of x is given to be 1 if x belongs to 0 to 1. So for 0 to 1, I take this integral as, I simplify this thing. Based on g of t, I define this function first, based on this g of t. Okay, so if x is lying in between 0 to 1, g of t is what? 1. So this will be g of x minus t dt. This will be g of x minus t dt. And plus, the remaining things will be what? 0. 0 to 1, maybe we are getting this thing. For the remaining regions, this will be 0 only, because the function is 0. Okay, so this is how we have simplified based on g of t. Fine. So now what I do is I convert this function in terms of one variable only. We are getting x minus t, right? And the dependent variable is t over here. The range is going from t is equal to 0 to 1. So what I do, I convert this thing into one variable. X minus t is equal to u, let's say. So dt will be what? Minus of du. Dt is minus of du. Okay. So we are getting t and u over here. So if t is 0, then this will be x, u will be x. And if t is 1, u will be x minus 1. So your new range is from x to x minus 1. And this is dt is minus of du. So take out one minus sign common. So this is du. And g of x minus u, this is g of u du. So next you can adjust this minus sign by rewriting this as x minus 1 to x, g of u du. So we have simplified our fx is this. This is our fx. Fine. So just like the previous question, we define this thing. We define this thing with the help of cases. So let's say case 1. In case 1, I define the function for what happens when x is lying in between 0 and 1. What happens when x is lying in between 0 and 1? If you carefully see, the options are also somewhere it's defined as 0 and 1, 1 to 2, and so on. Likewise, they have given the options. But here, the first case, what we can see is what happens for x is lying in between 0 and 1, because that's how we can, we have to define the function. So if x is lying in between 0 and 1, so x minus 1 will lie in between minus 1 to 0, minus 1 to 0. So what will happen over here? This integral will become integration x minus 1 to 0. We can break in this way, because x minus 1, the lower limit is what? X minus 1. This is the lower limit is x minus 1. So x minus 1 to 0, it's breaking at 0. So x minus 1 to 0 du plus, then the next limit will be, the next range will be 0 to, we are taking from x minus 1 to 0, then 0 to x. Okay, so 0 to x, d of u. So x minus 1 to 0, and then from 0 to x d. So now we see what happens with g of u. So g of u, here g of u is what? When x lies in between, when this quantity, when u lies in between x minus 1 to 0, it's still less than 0, right? It's still less than 0. So any quantity which is less than 0, your g of u will directly become 0 from here. G of u is 0 for x less than 1, less than 0. And when x lies in between, u lies in between 0 and x, it's less than x, right? But more than 0, and more than 0 this will be 1. More than 0 this will be 1. Okay? Because here, this is lying in between 0 to x, and x is less than 1. So technically, this is the overall quantity lies in between 0 and 1 only. So g of u will be what? 1. Okay? So next you simplify this thing. So this is straight away 0. And this is basically 1 du, which means u, and so x. So this will be x. Next, we check for case 2 similarly. So case 2, in case 2, we are getting a similar kind of thing in option A. Option A, we are getting x over here if x lies in between 0 and 1. Let's check for this as well. X belongs to 1 to 2. So let's check for this as well. X belongs to 1 to 2. Okay. So when x belongs to 1 to 2, x minus 1 will belong to 0 to 1. Okay. So here, can I say from here, the new range will be from x minus 1 to. So this integral will become x minus 1 to integration x minus 1 to 1 d of u plus then 1 to x and then 1 to x, because the new range upper limit will now become 1, x minus 1 to 1 and then 1 to x over here. Okay. So anyways, this quantity is what? X minus 1. Here, x minus 1. This integral is going from x minus 1 to 1. So it's less than 1. So less than 1 way we are getting g of x to be 1 itself. So this will be 1. And similarly, this is going from 1 to x. And in 1 to x, these quantities were more than 1 but less than x. And x is less than 2. So somewhere lying in between 1 and 2 only. Okay. So more than 1 may this is, so more than 1 may this is 0 basically. This exceeds 1. So this will be 0. G of u will be 0 because g of x is 0 over here. So g of u will be 0. So 0 times of dx. du basically. So next is we solve this thing. So this is once again 0. So this will be 1 du, which means u. And so this finally becomes 1 minus x minus 1. And so this is 2 minus x. So this becomes 2 minus x. So in between this interval, we are getting 2 minus x. So definitely option A must be correct. You can check for the remaining versions as well. For otherwise, they have said you can check for 2 to 3 as well. For 2 to 3, you can define similarly. You can make case 3. You can check for case 3. Define case 3 as x belongs to 2 to 3. Then find what is x minus 1. And similarly, you define this thing. For the remaining values, you will see that this will straight away become 0. Because 2 to 3 you are taking more values, right? 2 to 3 you are taking more values on that side. Okay. More values on that side. So definitely both of these integrals will become 0. G of u will be straight away 0 in that case. So definitely option A must be correct. Okay, next we have this question number 20, which says that L is given to be this limit n tends to infinity, n plus 100 whole raised to the power of 5 upon log n minus 50 base e. This is the power given. Okay. So first thing is what? First we check the form of this question. What is this? As n tends to infinity, this is of the form infinity raised to the power of 5 upon infinity, which is tending to 0. So we are having this complete form is basically infinity raised to the power of 0. This is of the form infinity raised to the power of 0. And for these kind of forms, always I have said, like in my batches, I have said this thing for infinity raised to the power of 0. Like in my batches, I have said this thing. Anywhere you see this infinity raised to the power of 0, or let's say 0 raised to the power of 0 is there, always you have to solve by taking log on both the sides. Okay. So what I do, I take log on both the sides and I simply solve this thing. So we have log of L. Log of L will be what? Limit n tends to infinity. 5 upon. This will come down. The power will come down. So 5 upon log of n minus 50 base e. And this is log of n plus 100. Both are natural logs. Okay. So 5 is just a constant. So you can take this out. So we are having limit n tends to infinity. So we have log of ln n plus 100 upon ln n minus 50. So next we are having this to be a standard form, which is infinite raised to the power of infinite divided by infinite. So this is 5 times of limit n tends to infinity. Next we can use the L'Hopital's rule. So this becomes limit n tends to infinity. 1 upon n plus 100 divided by 1 upon n minus 100, n minus 50. You reciprocal this thing. The form is still not gone. The form is still not gone. Again, we are having this to be n minus 50. This finally becomes n minus 50 divided by n plus 100 over here. Okay. So we can say from here, we are getting once again, if you use this L'Hopital's rule, you will be getting 1 by 1. So the value of this limit will be 5 in this case. Once again, differentiate this thing. You'll be getting 1 in the numerator and 1 in the denominator. So value of this limit will be 5. So log of L is 5. So L is what? L is e raised to the power of 5. L is e raised to the power of 5. Now, e raised to the power of 5, the value of e is 2.718, or approximately you all can take it to be 3 raised to the power of 5, let's say. Approximately, I'm saying you all can take it to be 3. And 3 raised to the power of 5 is approximately 243 only. So this quantity is somewhat less than 243. Okay, 2.718 whole raised to the power of 5 will be somewhat less than 243. Okay, so definitely option C must be correct. L must be lying in between 32 and 243 because the maximum range is 243 possible. This cannot exceed beyond 243. So L is less than or equal to 243 and greater than 32. Okay, next we have this question which says that let ABCD be positive integers such that the product ABCD is equal to 999. Then the number of different order 4 tuples ABCD is 4. So we have to find the number of positive integral solutions of this particular equation ABCD is equal to 999. So one thing we can clearly say from here, 999, we can factorize 999 because always for these kind of questions, these are very common type of questions. You learn this thing in division and distribution. When you learn combinatorics in permutation and combination, there is one topic, subtopic, what you call as division and distribution. So there you learn these kind of questions. So ABCD is equal to 999. This thing is given. And 999 can be factorized. 999 is basically 9 times of 111. So 9 times of 3 times of 37. We can write this as 9 times of 3 times of 37. 9 is again 3 cube. And this is one more 3 over here. So this is nothing but 3 cube. 3 square multiplied by 3 raised to the power of 1. So 3 cube multiplied by 37 raised to the power of 1. Okay. So this is the factorization. So logic is what? What is the logic to solve these kind of questions? So total we are having 4 objects over here. 4 objects. 3 plus 1, 4 objects. Okay. So total there are 4 objects. Out of which there are 4 objects in total. Out of which there are 3 identical objects. Out of which there are 3 identical objects and 1 different object. Okay. So 3 identical 3s are there. Okay. 3 identical 3s are there and 1 different object. So 137 is there actually. So what do we have to do for positive? We have to find the positive integral solutions. So for positive integral solutions, what do? Is we distribute the 4 objects into 4 boxes. Okay. We'll distribute the 4 objects into 4 boxes A, B, C, D. Let's say we are having 4 boxes like this. We are having the boxes in this sense. Okay. We are having 4 boxes. So what do? Is we will distribute these 4 objects into 4 boxes A, B, C, D. Okay. 4 objects means 3 identical and 1 distinct objects is 3 identical balls and 1 distinct ball is there. Let's say 3 red balls are there and 1 blue ball is there. So those 4 objects are distributed in these 4 boxes. So we have to see for the number of ways of distribution over here. So first thing is basically we can distribute the 137. Let's say for this one, we can distribute this 137 into any of these 4 boxes. So for this 37, we have all total 4 options. For this 37, we are having all total 4 options. Okay. Now to distribute the remaining 3 identical objects among these 4 persons, or let's say 3 boxes, the remaining 3 boxes of the remaining 3 boxes you take up. So to distribute these 3 identical objects among these remaining 3 boxes or the remaining 3 persons, okay, how will I distribute this thing? Also, there is one more condition. You have to distribute such that the empty groups are allowed because they haven't mentioned that each should get at least 1 object. Each of the boxes should get at least 1 object. So empty groups or empty boxes are allowed in this case. So in how many ways we can do this? Okay, so next what we do? Next we distribute these 3 identical objects among the 4 persons. Okay. So I'll distribute these 3 identical objects among the remaining 4 persons. So let's say here there is one condition which needs to be maintained over here. 3 identical objects among which is 3 identical objects are being distributed among 3 persons or 3 boxes, let's say, such that empty groups are allowed. Because they haven't mentioned that each should get at least 1 object. They haven't mentioned this thing. So empty groups are allowed in this case. Empty groups or empty boxes are allowed. So the number of ways in this case will be, you know the formula. The formula is basically n plus r minus 1, c r minus 1. Right? So 3 plus 4 minus 1, c 4 minus 1. That is Basically, we are getting this to be 65. This is 65. Okay, and 65 is directly 20. And this is the number of ways in which three identical threes can be distributed into the four boxes over here. Okay, so the total number of ways, final answer, your total number of ways will be what? 20 multiplied by 4. 20 multiplied by 4, which is 80 actually. So option C must be correct. Okay, next we have this question which says that in a certain test, there are n questions. At least I questions were wrongly answered by 2 to the power of n minus I students, where I is equal to 1, 2, and so on till n. If the total number of wrong answers given by all the students is 2047, then n is equal to what? So first of all, total there are n questions, and at least I questions were wrongly answered by 2 to the power of n minus I students. So at max to max, if I is equal to n, so at least n students, can I say at least n students? Max to max, I can be n, right? So at least n students or n questions, at least n questions were wrongly answered by, at least n questions were wrongly answered by 2 to the power of n minus n, which is 2 to the power of 0 students, which is 1 student. Okay, at least n questions. At least means at least n or more than n. Now, more than n is not possible. So at least is the wrong word to use over here because this is exactly n questions. Exactly n questions were wrongly answered by 2 to the power of 0, which is 1 student. Right? So next we see the remaining cases as well. Now suppose if n is equal to now suppose if I is equal to 1. What is the meaning of this I is equal to 1? We are seeing for exactly n questions. Okay, now we see the remaining cases. What happens? We are seeing the case where exactly n questions were wrongly answered by these many students. Okay. Now what happens for the next case? The next case is basically exactly n minus 1 questions. What happens for n minus 1 questions? Okay. At least n minus 1 questions are wrongly answered. Okay. What happens for exactly n minus 1 questions are wrongly answered? So what should be the answer over here? What should be the logic over here to be solved? Exactly n minus 1 questions are wrongly answered. We have to find the number of ways over here. Okay. So the logic for this question is actually one thing you need to understand over here. Let's say for instance, at least what you need to understand over here is, let's say you want to figure out what is at least n minus 2. This is a very famous question. At least n minus 2 wrong answers. You want to figure out what is the meaning of at least n minus 2 wrong answers. What is the meaning of this thing? This will include exactly n minus 2 wrong answers, right? Exactly n minus 2 wrong answers, and also this will include more than n minus 2, means exactly n minus 2 wrong answers. Also this will include exactly n minus 2 means what? N minus 2 including n minus 2 as well as more than n minus 2. So this includes exactly n minus 2 wrong. This also includes exactly n minus 1 wrong. Okay, and finally this also includes n wrong answers. Okay, so we can say one thing that exactly n minus 2 wrong will be at least n minus 2 wrong, minus at least n minus 1 wrong. This is kind of a generalization principle of the at least kind of questions which you learn for your board exams as well. It's kind of more of a generalization based type of thing. Okay. Because from when you learn these kind of keywords, you must have heard in permutation and combination. You must have heard about these kind of keywords. Like when at least is being used, what do you just simply you subtract from the total. From the total, you subtract the remaining not included wala part. So kind of here, it's kind of more of a generalization of this at least wala concept. So at least n minus 2 wrong minus at least n minus 1 wrong. Okay. So here, n minus, let's say for this thing, n minus 1 wrong. So how many n minus 1 wrongs are there? So at least n minus 1 wrong and then 1 less than this. So at least n wrong. At least n wrong. So basically this will be 2 to the power of n minus 1. At least n minus 2 wrong. At least n minus 2 wrong. At least n minus 1 wrong. And then minus at least n minus 1 less than this means at least n wrong. So 2 raised to the power of n minus n. At least n wrong. Okay. Similarly, the next one. For exactly n minus 2 wrong. For exactly n minus 2 questions wrong. What is the number of ways? What we have to do basically, at least n minus 2 wrong. We have to subtract this. So n minus 2. And then subtract minus at least n minus 1 wrongs. At least n minus 1 wrong, which means n minus 1. Fine. And so on. This will continue. This will continue till where? N minus 1, n minus 2, and so on till this will continue till 1 question. Okay. 1 wrong. 1 wrong question. So 1 wrong question clear. For 1 wrong question, we'll be having 2 to the power of n minus 1 minus 2 to the power of n minus 2. At least 1 wrong. At least 1 wrong. And then 1 less than this. So these are the total number of questions. And there's one thing what you need to focus on is, so in total, there are how many questions? This is the number of questions where they have done at least exactly n minus 2 wrong. Exactly n minus 2 wrong. N minus 1 wrong, n minus 2 wrong, and so on. Exactly n minus 1 wrong, n minus 2 wrong, and so on till 1 question. So here, what we have to do is, for in total, how many are there? For the first one, in total, there are n minus 1 mistakes, n minus wrong questions. For second one, we are getting n minus 2 mistakes in total, and so on and so forth. Likewise, the last one, 1 mistake is there. So their sum is given to be 2047. This sum is given to be 2047. Okay, so we need to evaluate this sum actually. We need to evaluate this sum. So once you find out, we just need to solve this series and then we are done. Okay. Also the first question is there, like at least is not the right word to use. So exactly n questions were wrongly answered by 2 to the power of n minus n, which is 2 to the power of 0. So 1 student. Okay, so 1 student. So in total, how many are there? So in total, how many is making mistake? In n. In total n. So likewise multiplied by n minus 1. So this 1 times of n will be there. So 1 times of n. So here we need to find the value of this series. So we are getting n plus, the series is n plus, then we are having 2 to the power of n minus, cancels out. This becomes 2 to the power of 1 minus 0, which is 1. So 2 minus 1. 2 to the power of 1 minus 2 to the power of 0. I'm writing this for the time being. Multiplied by n minus 1 plus, similarly, the next term is what? 2 square. 2 square minus 2 to the power of 1. 2 square minus 2 to the power of 1 into n minus 2, and so on. Continue still. Last term is basically 2 to the power of n minus 1 minus 2 to the power of n minus 2. Next term is what? Next term is 2 cube minus 2 square. Next term is 2 cube minus 2 square, and so on and so forth. So this goes up till 2 to the power of n minus 1 minus of 2 to the power of n minus 2 multiplied by 1. Right? So once you simplify this thing, so we are having further, this is n plus 2 minus 1. This is directly 1. So n minus 1 plus 2 square minus 2, which is 2 times of n minus 2. Next term is basically, I'll write one more term, 2 square. Next term is what? Next term will be 2 cube minus 2 square. So you can take out 2 square common from there. This will become n minus 3. And so on till, from here also you can take out 2 to the power of n minus 2 common. So this will become minus 1. So this is times of 1. Okay. So this is the final series we are having. So what is this? This is an AGP. This is an AGP. this much portion. This much portion is an AGP, which you can clearly see, because this is a GP. This is a GP given 2 square, 2 raised to the power of 0. So 2 square, 2 cube, and so on till 2 raised to the power of n minus 2. A GP is there, and then n minus 1, n minus 2, and so on till 1. It's an AP. Fine. So I'll consider this to be S, and then I'll solve this thing. So S is basically n minus 1 plus 2 times of n minus 2 plus 2 square times of n minus 3. Okay, and so on till 2 to the power of n minus 2 times of 1. This is the series given. So what do we do is we solve this by the shifting method. There is one specific way of solving these kind of series of AGP. What do we do is we solve this by the shifting method. Okay, we shift and then we multiply by 2. Okay, we multiply by 2 and then we'll shift this thing. So it's a standard way of solving this thing. So we multiply by 2, we multiply by 2, and then we shift this thing and write this. So this becomes 2 times of n minus 1. Okay, 2 times of n minus 1 plus 2 square times of n minus 2, and so on. So last term will be 2 to the power of n minus 2 times of 2 plus 2 to the power of n minus 2. So then what we are going to do is, so next we need to find out S. So what I do, I simply subtract these two. So this will become 2S minus S, which is just S. S is equal to, okay, so this becomes 1 minus N plus, and you will get the simplifications from here, 1 minus N, and then this becomes 2 times, or you get 2 common from here, right? From all the terms you'll be getting 2 common. So 2, this will become what? This will become n minus 1 minus of n. N cancels out, so minus 1 and then minus plus 2. So 2 minus 1 is just simply 1. So you will be getting 2 plus 2 square, similarly 2 plus 2 square plus 2 cube, and so on till 2 to the power of n minus 1. Finally, we are having this series, and this is a standard series which you can solve, right? So likewise, we are getting S to be 1 minus n multiplied by 2 plus 2 square, and so on. So this becomes this is what? This is basically a GP. So 2 times of 2 to the power of n minus 1. How many terms? N minus 1 terms are there. So 2 to the power of n minus 1 minus 1 upon 2 minus 1. It's a GP, right? So we are getting n plus S. N plus S is equal to, this is 1. So we are having 1 plus, you multiply this thing. So we will be having 2 to the power of n minus of 2. And this is, finally, we are having 2 to the power of n minus of 1 on the right hand side. And this is n plus S, right? So what do we have to find? We have to find S. We have to find N, sorry. We have to find N. So the total number of wrong answers is, which is given by all the students, is basically 2047. So N plus S is given to be 2047, right? This N plus S will give you this series. N plus S will give you this series. This sum was given to be 2047. Okay, so this is 2047. So 2047 plus 1 will give you 2 to the power of n. We can find what is 2 to the power of n from here. So this is 2048 is 2 to the power of n. So definitely n will be 11 from here, because 2 to the power of 11 is 2048. So option B must be correct. Okay, next we have this question which says that for n greater than or equal to 3, there are n straight lines in a plane, no 2 of which are parallel, and no 3 passes to a common point. The points of intersection are joined, then the number of fresh line segments that's created is what? So first of all, this much is a very standard condition. There are n line segments, there are n lines in a plane, so that no 2 of which are parallel and no 3 passes to a common point. This is a very standard problem. Till this much is a standard problem. So their points of intersection. So we are taking those lines and their points of intersections are joined. Then we have to find the number of fresh lines which are being formed. So total point of intersection will be, the total point of intersections possible will be NC2. Total point of intersections which are possible from the first 2 lines. There are n lines in a plane, no 2 of which are parallel and no 3 passes to a common point. So total possible lines, total points of intersection will be NC2, which is n into n minus 1 divided by 2. Okay. So now each of these lines, now we have to figure out that each lines have how many points. So since each lines will be cut by n minus 1 lines, so each lines will be having n minus 1 points. Okay. So each of these lines have n minus 1 points. Okay. So now if we join these n minus points, the question is how many new lines can be formed? That's what the question says. So once you join each of these n minus 1 lines, so how many new lines can be formed? So what can I say from here? So basically, you take the total points, which is n into n minus 1 divided by 2C2. Okay. So you make the selection over here. You need 2 points. Okay. So for this line, for this selection, you make this as n into n minus 1. So basically NC2, C2. So from the total, you select these 2 lines, 2 points. So n times of n minus 1 divided by 2. And from there, you have to subtract some cases. Divided by 8 common from here. So finally, we will be having this is n plus, we'll be having n plus 1 minus 4, which is n minus 3. So n into n minus 1 into n minus 2 into n minus 3 divided by 8. Option C must be correct. Okay, next we have this question which says that let D be the side length of the largest possible equilateral triangle that can be put inside a square of side length 1. Then we have to approximately find the value of D. Now there is a standard way of putting this equilateral triangle in a square. In general convention, we take it in this form. This is how we place one equilateral triangle in a particular square. Now, one thing we can figure out, this equilateral triangle, we are fitting this equilateral triangle inside the square. So obvious regions, some regions are definitely left out. So the area of equilateral triangle will be definitely less than this area of the square. So we can use the fact. So area of this equilateral triangle will be less than the area of the square. Okay. Root 3 by 4 d square will be less than 1 because this is the length of this is d actually. The length of this is d and the length of the square is basically 1 unit. The side lengths are 1 unit each. Okay, so root 3 by 4 d square must be definitely less than 1. The area of the square is 1 only. So what can I say from here? D square must be less than 4 by root 3. So d is less than, I can say from here d is less than 2 by 3 to the power of 1 by 4. So d is definitely less than 2 upon 3 to the power of 1 by 4. Okay, so it seems like option C is correct. We just need to figure out the minimum value of d. We need to find the lower value of d as well, minimum value of d. Okay, so for this, we can take the help of this Pythagoras theorem. Let's say this is x. Let's say if this is x, so this is 1 minus x, right? If this is x, then this is 1 minus x. And if this is similarly by symmetry, if this is x, this will be also 1 minus x. So one thing we can do, we can use this Pythagoras theorem, which is d square. D square is what? D square is 1 plus x square. And similarly from this region, we can say this is the same as 1 minus x whole square plus 1 minus x whole square. So 2 times of 1 minus x whole square. So we simplify this thing. So this is basically 2 times of 1 minus x square, 1 plus x square minus of 2x. And this is 1 plus x square. We solve for x from here. So 1 plus x square, 2 plus 2x square minus of 4x. Right? So this is basically x square. Then we are having x square minus 4x, x square minus 4x, and minus plus 1 is equal to 0. We solve for x from here. So what is x? X will be minus b plus minus root over of b square minus 4ac. So 16 minus 4 divided by 2. So this becomes 2 plus, this is 12. So 2 plus root 12 divided by 2, which is 2 root 3. So this becomes, this was 4. So 4 plus 12 divided by 2. So this becomes 2 plus root 3. So 2 plus minus, basically 2 plus minus root 3. Now which one to consider, plus or minus? 2 plus root 3. Here x, we have to take care of this thing that x here is less than 1 because the total length is 1. Okay, so 2 plus root 3 is actually more than 1. If x is 2 plus root 3, this 2 plus root 3 is more than 1. So this cannot be more than 1. So x must be definitely 2 minus root 3. X definitely must be 2 minus root 3. Okay. So if x is 2 minus root 3, then we can find the value of this d square from here. If x is 2 minus root 3, we can find d square from here. What is d square? D square will be 1 plus 2 minus root 3 whole square. So this is 1 plus 2 minus root 3 whole square. This is 4 plus 3 minus of 4 root 3. So this becomes 8 minus 4 root 3. And 8 minus 4 root 3 is definitely more than 1 because 8 minus 4 times of this is 1.7, approximately 1.7. Let's say I'm taking. So this is, close to 1 point. You can take it 1.732 as well. So close to, this is approximately 8 minus 4 times of this quantity will become 6.928, somewhere around 6.92, close to 6.92. So 8 minus 6.92 will be approximately 1.072. And this is definitely more than 1. Definitely this is more than 1. Option C must be correct. Okay, next we have this question from limits. So an is given to be some series, and we have to find the limit of this thing. We have to find the limit of an as n tends to infinity. So now here what I can do is, here the maximum denominator is what? Root over of n to the power of 6 plus n, right? So as denominator increases, the overall fraction will decrease. As denominator increases, the overall fraction will decrease. So that will give you the lower bound. And as denominator decreases, the fraction will increase. Okay. The vice versa, basically. As denominator decreases, the fraction will increase. So what we can do, we can try to establish some inequality over here. So here, with the lower bounds will be what? With the greatest denominator. So n to the power of 6 plus n will give you the lower bound, right? So I'm giving n to the power of 6 to all of these terms. How many terms? How many terms we have taken? N terms are there. So there is one more n square, and n square over here. Okay. Less than a, less than. And the maximum value will be given by the lowest denominator, n to the power of 6 plus 1. Because as denominator decreases, the fraction will increase. So n square plus n square upon square root of n to the power of 6 plus 1, and so on till n square upon n to the power of 6 plus 1. Okay. So what will this give? How many terms we have taken? Total n terms are there. So n times of this thing. So this will become n cube upon square root n to the power of 6 plus n less than an less than n cube upon square root n to the power of 6 plus 1. So next you simply take the limits on all three sides. So as limit n tends to infinity, limit n tends to infinity, we solve these individually. Okay, and then we'll simply use the sandwich rule. So limit n tends to infinity, this will become, you divide, you from the denominator, you take out n to the power of 6 common from the square root. So this will become n to the power of 3. And this n to the power of 3 will come out. N to the power of 3 will cancel out. And this becomes square root of 1 plus 1 upon n to the power of 6. This will cancel out. This will cancel out. So finally, we will be having, as n tends to infinity, this will tend to 0. So this value will be 1. And similarly, you check for the right hand side as well. So this becomes limit n tends to infinity, n cube upon, you take out n cube common. So this becomes, again, similarly, okay, this was n. So 1 upon n to the power of 5. This was n, right? So 1 upon n to the power of 5. So this tends to 0. So this will be tending to 1. And similarly, this will become n to the power of 6. So 1 plus square root of 1 plus 1 upon n to the power of 6. This will cancel out. And this will once again tend to 1 because this is tending to 0 as n tends to infinity. So both these limits will tend to 1. So by sandwich theorem, we can say that the limit is equal to 1. Option B must be correct. Okay, next we have this question from inverse trigonometry. Let n be a positive integer. We have to find the value of this summation. It's summation series based question, and these questions are quite routine questions actually. So we have to find the value of this series. Summation k is equal to 0 to n tan inverse 1 upon 1 plus k square. We have to find the value of this thing. I'm rewriting this in this way. We have to express this in the form of difference of tan inverse wala formula. So k is equal to 0 to n. This will become tan inverse. Can we write this as? This is 1 plus. We can write this as k times of 1 plus r. 1 plus k, sorry. And we have to express the difference of these two in the numerator. So we can write this as k plus 1 minus of k. And this is quite visible from here. K plus 1 minus of k will give you 1 itself. Okay. So next we have to solve this. So now we can express this and write this as summation k is equal to 0 to n tan inverse k plus 1 minus of tan inverse k, using the formula of tan inverse a minus tan inverse of b, so that this will become a telescoping sum. Now you can clearly see that this will become a telescoping sum. You can check the difference. Like this becomes, the first term is what? Put the value of k is 0. So this will become tan inverse 1 minus tan inverse of 0. Next term is plus tan inverse of 2 minus of tan inverse of 1. Then tan inverse of 3 minus of tan inverse of 2, and so on. This will continue till tan inverse of n plus 1 minus tan inverse of n. So you can see the cancellations. This term and this term is getting cancelled, this term and this term. So this term and the next term will get cancelled. And similarly, some term over here and some term over here will get cancelled. So what is remaining? Tan inverse n plus 1. What is remaining? Tan inverse n plus 1 minus tan inverse of 0. Tan inverse of 0 is straight away 0. So answer will be tan inverse n plus 1. Option A must be correct. Okay, next we have this question where a function is given fx to be x square plus 18 times of x minus 4 times of x plus 4 minus of 2. Then we have to find how many roots this will have, how many distinct real roots or one real root, whatever the number of real roots are there, we have to evaluate the roots of this particular function. So overall, we have some terms over here. You need not multiply the same because, multiplying this is a hectic kind of thing. So you need not multiply this. So we are having some terms and then we are subtracting by 2 actually. So what I do, I try to focus on the graph of this thing, because what is the meaning of this thing? Can we figure out the roots of this much portion only? The roots of this many factors? Obviously, yes. This will give you complex roots. So the remaining ones, x minus 4 will give you 1 root, x will give you 0, and x plus 4 will give you minus 4. So these are the roots actually. These are the real roots of this polynomial. Let's say this is gx actually. So we are having gx minus 2, something like this. Fx is written as gx minus 2. Okay, so suppose I try to draw the graph of this function. Okay? Because see, by differentiating this and then you will try to figure out, you will try to analyze this thing, that will also work out, but that will be very lengthy. Okay, So we have to use some shortcut approach over here. So now look at this thing. So I'll try to draw the graph of gx actually. Forget about this -2. I'll try to draw the graph of gx. So don't you think, gx is having the real roots to be 4, 0, and -4. Okay, 4, 0, and -4. At 0, this will cut. At 4, this will cut, and -4, this will cut. Okay, so the graph will be somewhat like this. The graph will be going somewhat like this. Go down, and then this will once again come up in this way. You can check this by the coefficient test over here. As x tends to infinity, the highest degree is basically what? The highest degree is 5, which is positive. Highest degree, the coefficient of x is positive here, right? So definitely for x tends to infinity, this will tend to plus infinity, and for minus infinity, this will tend to minus infinity, because here we are having odd powers. Okay, so that the graph will, for plus infinity, this will go to plus infinity, and for minus infinity, this will go to minus infinity. And these are the roots we have pointed out. Okay, so now we have drawn the graph of gx. Now, what is gx -2? So gx -2 is basically a transform graph. Gx -2 is technically, we are drawing the same graph, and then we are shifting the graph by 2 units down. So the graph will simply come down by 2 units. So the graph will simply come down by 2 units, somewhat like this. The graph will simply come down by 2 units. Entire graph will come down by 2 units. This is the graph of gx -2. Got it? This is the graph of gx -2. Now, there are several cases. We'll have to take all the cases. This is one of the cases. There are several cases which we need to take care of. There is one more case. Like here we have the point of maxima. We don't know the point of maxima. There is one more case. What happens? Like here we are getting one real root. In this red scenario, we are getting red graph. We are getting one real root actually, right? Now what if the graph goes like this, touches the x-axis over here, and then comes down like this? Touches the x-axis, then comes down like this. Okay, touches the x-axis and then comes down like this. So in such case, you can see that there are two repetitive real roots. And then one distinct real root is there. Two roots are repeating, and then one distinct real roots, right? And there is one more case which is possible. So one more case which is possible is when the graph comes like this, cuts the x-axis, and then comes down like this, and then goes in this way. There is one more case. So in this case, you'll be seeing that there are how many? 1, 2, 3 distinct real. So these are the possible cases. So can I say that this will completely depend on whichever graph we are supposed to choose? This will completely depend on this maximum value. Okay. But how do we figure out this maximum value? Do we differentiate? No. Let's try to analyze this thing without differentiating. Can we just use some sort of shortcut kind of thing? Because this is negative. Anyways, this is negative, right? Somewhere lying in between -4 and 0. So you take the value of x to be -1, let's say. Take the value of x to be -1. What will happen? -1 is one of the simplest possible value, right? For x is -1, we don't know what is this point. I'm just taking some random points over here, -1. Anyways, this point is lying in between 0 and -4. So -1 is definitely one acceptable value. So I'm taking x to be -1. So this will become 19 times of -5. 19 times of -5, and this becomes -1, and this becomes 3. So that's 19 times of 5 times of 3. So 19 times of 15. 19 times of 15, which is approximately, I think this is 285. 19 times of 15 is 285. Fine. 19 times of 15 is 285. Now, the thing is, look at this thing. For -1 itself, we are getting, at x is equal to -1, we are getting 285. For gx, I'm saying. For gx, you are getting, for at x is equal to -5, this value is getting to be 285. And 285 minus 2 will be slightly, less than 285, which is 283, which is a huge value. Okay, so at -1 itself, at -1, the graph is way too up. Okay, the graph is way too up, like this. The graph is way too up. Getting my point? So by subtracting -2, If you are subtracting -2, then the graph will slightly come down. Slightly the graph will come down. Got it? So definitely this graph will have three distinct real roots, 1, 2, and 3. Definitely the graph will have three distinct real roots. Option B must be correct. Fx is e to the power of x minus 1, then we have to evaluate this limit. So now if you carefully see, this is actually limit x tending to 0. You start plugging the values over here. So fx is e to the power of x minus 1 divided by x. Then fx is, then we are having f of x by 2. F of x by 2 is basically e to the power of x by 2 minus 1 divided by x. And the next term is what? E to the power of x by 2 square minus 1 divided by x, and so on. It goes up till e to the power of x by 2 to the power of k minus 1 divided by x. So this is one of the standard forms of limits. But this is actually e to the power of x by 2 minus 1. So you have to divide by 2 and multiply by 2 over here, because this and this needs to be the same. Similarly, you have to divide by 2 square and multiply by 2 square over here. This and this needs to be the same, and so on. So multiply and divide by 2 to the power of k. So this quantity becomes 1. Now this quantity becomes 1. So finally we are having, once you plug in the limit, so this becomes 1 plus, this is 1 plus half square, and so on till 1 upon 2 to the power of k. Right? So here, what is this? A GP. Right? A GP is there. So 1 times of 1 minus half raised to the power of k plus 1, because there are k plus 1 terms starting from 1 to k. So, sorry, starting from 0 to k, we are having k plus 1 terms. So 1 minus half. So this becomes 2 times of 1 minus half raised to the power of k plus 1. Right? And then you simplify this thing. So this becomes 2 minus 2 times of this thing. So this is 1 raised to the power of k plus 1 is 1 only. So 1 upon 2 divided by 2 raised to the power of k plus 1, which is 1 upon 2 to the power of k. So option A must be correct. Okay, now we have this product series given. An is this product series, and then we have to find the limit n tends to infinity of this product series. Okay, so now there are several methods to solve this thing. There are several ways, like the best way, the more easier ways, you just simply, try to see the cancellations. You'll try to factorize this thing, a cube minus, use the formula of a cube minus b cube, try to factorize this thing and try to see the cancellations, which is actually complicated. The most difficult part is actually, the most difficult part is to see the cancellations. The cancellations are easily not visible here. Okay, so what is the best way to solve this thing? So what I do, I rewrite this thing as limit n tends to infinity. This is actually product of k is equal to 2 to n. Product of k is equal to, it starts from 2, right? 2 cube, 3 cube, and so on. Okay, and this product is, this is given to be 2 to n, k minus 1, k cube minus 1 divided by k cube plus 1. This thing is given. I'll deal with this product only. This is the best way to solve this thing. Okay, and this is exactly how you're supposed to solve this thing. Okay, without too many cancellations and calculations. So product of k is equal to 2 to n is product of k is equal to 2 to n is basically k cube minus 1. I simplify this thing as k minus 1 times of k plus 1. Sorry, k minus 1 times of k square plus k plus 1 divided by, similarly, k plus 1 times of k square minus k plus 1. So now over here, this is actually product of k is equal to 2 to n. Now what I do is I'll distribute the products. Product is distributive over products. Summation is distributive over summation. So product is distributive. I'm distributing the products to each of them. This will give the same value. I'm distributing the products to each of them. K square plus k plus 1 and divided by product of k is equal to 2 to n, k square minus k plus 1. Okay. So next, what are we going to do is we will be doing something which is called as indexing. I'll be changing the variable over here. So once you change the variable over here, this will also change. So let's say you are increasing by 1 units over here. You are increasing the variable by 1 unit. Here, you are increasing by something, some quantity. So you have to decrease by the same quantity over here. Inverse. And vice versa. Let's say you are decreasing by some quantity over here. So you have to increase by the same quantity over here. Okay, let's say over here, what I'm doing is I'm rewriting this as This is the same thing as k minus product of k minus 1. I can write this as product of k is equal to, I am writing k minus 1 as k. So I'm increasing by 1, right? I am increasing by 1. I'm adding 1 over here. So you have to decrease by 1 over here. So this product should start from 1 to n. This is called indexing of the products or summation. The same thing can be done for summations as well. Okay, both will give you the same product. Divided by, okay, this product was 2, starting from 2 to n. This was 2 to n. So divided by, similarly, here I am making this as 1. So I'm subtracting 1 over here, right? I'm subtracting 1. So you have to increase by 1 over here. So this should start from 3. It's 3 to n. It should start from 3. Okay. And then multiplied by k is equal to 2 to n k square plus k plus 1. Similarly, I'll keep this as same and I'll make some changes over here. K is equal to, I'll make some changes over here. Here, k square minus k plus 1 can be converted into k plus 1, k square plus k plus 1. In what sense? Let's say I'm taking k square plus k. This is k square minus k plus 1. If I replace this by k plus 1, this will become k plus 1 whole square minus of k plus 1, okay, and plus 1. So don't you think this is nothing but k square plus 2k plus 1 and minus k minus 1 plus 1. So this cancels out. So what are we left out with? K square plus k plus 1, which is nothing but the numerator. So if I replace this by k plus 1, k by k plus 1, if I replace this by k plus 1, k by k plus 1 means we are increasing k by 1 unit up, right? So you have to decrease this. So you have to decrease this to 1. Okay, this is what we call as indexing. So what will happen? There will be some cancellation. We can cancel out some terms over here. See, in the numerator, we are getting 1 times of 2 times of product of k is equal to 3 to n times of k divided by, this is product of k is equal to 3 to n k. Then multiplied by, similarly, here we are getting product of 2 to n. I'll keep this as product of k is equal to 2 to n, k square plus k plus 1. And we have also converted this denominator into the same product, k square plus k plus 1, right? But we have to match with this thing. So this starts from 1, right? This starts from 1, but this starts from 2. So you have to start from 2 itself. So what is the value of this thing at k is equal to 1? So 1 plus 1 plus 1 will give you 3. So 1, 3 will come over here. So now you can see the cancellations. This will cancel out. This will also cancel out. So 1 times of 2 is 2 only. So 2 divided by 3. So answer is 2 by 3. Option B must be correct. Okay, so we have this question now, which says that a subset U1, U2, U3, U4, and U5 of the first 90 positive integers can be selected in 90 C5 ways. Let U max is max of U1, U2, U3, U4, and U5, and similarly U min is minimum of these 5 quantities. Then the arithmetic mean of U max plus U min over all such subsets is what? So first, what we do is we first find what is U min. U min is minimum of all these values. So the minimum possible sum. First of all, we know that the possible ways of selection is basically 90 C5 ways. So for any subsets, the largest sum possible is what? 90. For any subsets, the largest sum which is possible is what? 90. So we start off with 90. So if we choose 90, then in what way we can choose the remaining ones? Let's say out of the 5 subsets, basically we are choosing 90 first. 90 is chosen first. So how many are remaining? 4 are remaining. Okay, 4 can be selected out of the remaining 89 ways. So 89 C4. And in a similar way, we do the remaining selections. Let's say if 89 is selected, then how many are remaining? Total 88 is remaining, out of which we will be selecting 4 ways, 4 subsets again. You know, 89 out of the 5, we have selected 89 first. So the remaining are what? Remaining beyond 89, how many are remaining? 88s are remaining. Beyond 89, how many are remaining? 88 is remaining. So out of which we are selecting 4 ways. So 88 C4, and so on. The series will continue. So 89 multiplied by 88 C4. So the next term is what? 87 multiplied by 87 C4, and so on. Continues. This will go up till 5 times of. The last term is what? Last term. You focus on the pattern over here. This is 89, 88, 87. So the last term is what? 4C4 only, where the prefix and suffix will be equal. And over here, if we are having 87 over here, if we are having 80, this is 87. If we are having 87 over here, this will be 88. Sorry, this will be 88. one more than this thing. For 89, we are having 90. For 88, we are having 89. For 87, we will be having 88. So for 4, we will be having 5. Okay. So this is basically your U min. Fine. So this is basically your U maximum. This is U maximum. I'm sorry. This is U maximum. U maximum will give you the maximum value because we are taking the maximum sum starting from 90. Okay. So can we find what is U minimum now? We can find what is U minimum. What is U minimum? The minimum possible sum is what? 1. Minimum possible sum is what? 1. Right? Minimum possible because they have taken the positive integers over here. So minimum sum possible is what? 1. So 1 times of the first one I'm choosing 1, right? So the remaining are what? 89s are remaining, out of which I have to choose 4. So 89C4 plus 2 times of next term is what? 2 times of 88. I'm choosing 2. So what is remaining next? 88. Then beyond 89, how many are remaining? 88 are remaining. So 88C4 plus 3 times of 87C4 and so on continues. This will continue till 4C4. This will continue till 4C4. Okay, now if here we are having 87, so see the terms are going in this way. 89, for 89 we are having 1. Okay, so for 88 we are having 2. 87 we are having 3. Okay, so likewise for 4 we must be having 86. So 4 we must be having 86. Okay. In this way you can think this is 1 means 90 minus 89. 88 means 90 minus, sorry, 2 means 90 minus 88. 3 means 90 minus 87. Okay. And so on. So 4 will be obtained if you take 86 over here. 90 minus 86 will give you 4. So in this way you can figure out the series, the last term. So you have to add this thing because they have asked to find the arithmetic mean of this thing. So U max plus U mean. So we have to find what is U max plus U mean first. So if you add this series, what will I get from here? So U max plus U min will give you. Now see, from you're adding the series, right? So 90 plus 1 is 91. 91 times of 89C4. Similarly, from here you'll be getting 91. From here you'll be getting 91 and so on. All the terms will be having 91. So 89C4. Now the question is easy. 89C4 plus 88C4 and so on till 4C4. So we have to just solve this binomial series, which is easy to solve if you know how to solve this binomial series. So there is something called which is the hockey stick identity. There is something called which is the hockey stick identity taught in binomial theorem. When you learn binomial series, K summation K is equal to R to N, KCR. KCR is basically RCR plus R plus 1 CR, okay, plus R plus 2 CR and so on till NCR. Goes up till N. How to identify this thing? The first term should start from RCR. The prefix and suffix are the same. And then you are changing this to R plus 1 CR. This will remain the same. This will change R plus 1, R plus 2 and so on. So we are having the same thing. And this formula is given by N plus 1, CR plus 1. N plus 1, CR plus 1. This is called the hockey stick or the Christmas stocking identity. So if you use this formula over here directly, so we are getting 91 times of this is N plus 1. So here what is N? N is the last term. N this goes up till 89, right? So 89 plus 1, CR plus 1. So 4 plus 1. So this is 91 times of 90C5. 91 times of 90C5. Now 90C5, they have already mentioned this is U max plus U mean. This is U max plus U min. So now they have said we have to find the arithmetic mean of U max plus U min. So we have to divide by the total number of quantities. So the arithmetic mean, the average basically. So total number of ways of selecting this is what? 90C5 only. The total number of ways of selecting this will be what? 90C5. So divided by 90C5. So 90C5, once you divide by 90C5, this will cancel out. So your option D must be correct, which is 91.